How to fix ping spikes and rubber banding in Valorant. Welcome back to Tenebalta. During our rigorous in-house testing, our technical team encountered severe ping spikes and frustrating rubber banding issues while playing Valorant. We immediately initiated a comprehensive diagnostic investigation to identify the root causes of these network instability problems. After extensive network traffic analysis and software debugging, we have formulated the ultimate diagnostic guide to permanently resolve your connection issues. Our testing showed that uncapped frame rates can severely choke network processing, leading directly to the rubber banding effect you experience in-game. To resolve this, open your Valorant video settings and set a strict limit on your maximum frame rate that matches your monitor refresh rate. By stabilizing the hardware load, we verified that the game engine syncs perfectly with server tick rates, eliminating the chaotic packet processing. Tenebalta's analysis revealed that improper network buffering settings cause extreme desynchronization between your client and the Riot servers. Navigate to the General Settings menu in Valorant and locate the Network Buffering option to optimize how packets are handled. We recommend setting this to minimum if your base ping is under 30, moderate for ping up to 60, and maximum if you consistently play above 60 milliseconds. During our background process monitoring, we identified that hidden game updates from clients like Steam heavily saturate available bandwidth. You must open all alternative game launchers and forcefully disable automatic updates during active gameplay sessions. This simple bandwidth management step drastically reduces sudden latency spikes caused by rogue data downloads. We discovered that corrupted local DNS caches frequently misdirect game packets, introducing artificial latency and connection drops. Open your command prompt as an administrator and execute the ipconfig flushtons command to purge the outdated routing data. Following this with a complete release and renew command cycle, instantly rebuilt a clean pathway to the Valorant authentication servers in our tests. Our network routing diagnostics confirmed that default internet service provider DNS servers are notoriously slow at resolving gaming server addresses. We successfully mitigated this delay by navigating to the network adapter properties and manually assigning Cloudflare or Google public DNS addresses. Implementing these primary addresses reduced initial connection handshake times significantly during our benchmark runs. While analyzing the protocol layers, our technicians noted that Valorant occasionally struggles with dual-stack network environments. By entering the Network Connections menu and completely unchecking the Internet Protocol version 6 option, we forced a stable connection. This intervention eliminated the packet routing confusion that was directly triggering rubber banding artifacts during intense firefights. Outdated controller drivers were found to be a massive bottleneck during our hardware layer inspection. We strongly advise visiting your motherboard manufacturer website to download and install the absolute latest Ethernet adapter drivers. Fresh network drivers resolved underlying hardware-level packet loss and ensured maximum throughput efficiency for competitive gaming. Windows actively reserves a portion of your bandwidth for system updates through the quality of service packet scheduler, which disrupts gaming traffic. Through our group policy editor deep dive, we adjusted the reservable bandwidth limit down to absolute 0%. This configuration ensures that Valorant receives unhindered, top priority access to your entire network capacity at all times. Our system monitoring tools flagged that Windows occasionally deprioritizes the Valorant executable during heavy multitasking scenarios. Launch the Task Manager, navigate to the Details tab, and permanently elevate the Valorant and Vanguard processes to high priority. This strict CPU scheduling forces your operating system to process incoming network packets for the game before any background applications. Tenebalta discovered a critical flaw where advanced power-saving features Forcefully put the network card to sleep between packet bursts. Open your device manager, access your Ethernet adapter properties, and strictly disable energy-efficient Ethernet and green power options. Keeping the network card in a state of maximum performance completely eradicated the micro-stutters we were experiencing in the practice range. Third-party overlay applications constantly poll their own servers for rich presence data, creating overlapping network requests that clash with Valorant. We tested disabling hardware acceleration and network features in communication applications and found immediate latency improvements. Shutting down these persistent background connections frees up crucial ports and removes unnecessary local network congestion. Strict firewall configurations often inspect incoming packets too aggressively, causing artificial delays in competitive shooters. We manually navigated to the firewall settings and created dedicated inbound and outbound exception rules for the entire Riot Games installation folder. Bypassing this packet inspection layer allowed the raw game data to flow seamlessly without security-induced micro-latency. During our physical hardware tests, we noticed that USB adapters and standard wireless connections suffer from massive signal jitter. We strongly urge you to abandon wireless protocols and connect your machine directly to the primary router using a high-quality Ethernet cable. The physical copper connection instantly stabilized our ping graphs and completely nullified all environmental wireless interference. Memory leaks inside aging router firmware are a common culprit that our lab consistently identifies as a source of network degradation. You must log into your router administration panel, flash the latest manufacturer firmware, and perform a scheduled weekly reboot. Clearing the router internal cache guarantees that the local routing tables remain pristine and fully optimized for continuous gaming traffic. Our packet fragmentation analysis revealed that incorrect maximum transmission unit sizes cause packets to split, doubling the required transmission time. By using the command prompt to find our network optimal MTU value, we eliminated unnecessary packet fragmentation at the local level. Setting the specific MTU integer for our adapter streamlined the data payload delivery directly to the game servers. Windows delivery optimization turns your computer into a peer-to-peer node, silently uploading update files to other users on the internet. We navigated deeply into the Windows Update settings and completely turned off this bandwidth-stealing background feature. Reclaiming our dedicated upload speed prevented the severe synchronization issues that occur when the game struggles to send your movement data. As a final definitive measure, our security layer investigation proved that a corrupted Vanguard installation blocks critical game telemetry. We utilized the system settings to completely uninstall Vanguard, followed by a clean system reboot and a fresh client-initiated download. Regenerating the anti-cheat kernel driver from scratch repaired the broken network hooks and restored flawless, lag-free gameplay in our final testing phase. Don't forget to follow Tenabalta for more.